We're going to be looking at volume for the next couple of lessons. Today's lesson is on calculating the volume of a prism. We know from a previous lesson that area is when we have the number of squares that cover a surface. Volume is the number of cubes to fill or fill up a 3D or three-dimensional figure, or a solid. So we're going to fill in a solid. Today's solid is going to be a prism. So just as a reminder, a prism has to have two bases. Those bases are the same polygon and they're parallel. Does not mean they are necessarily the top and the bottom. What finishes out the prism is the rectangle. So if you have a bunch of rectangles connecting two polygons, you have a prism. The name of the prism is determined by the shape of the base. So if we have two triangles and a bunch of rectangles, it's a triangular prism. In the case of our diagram, we have a hexagon top and a hexagon bottom. So in this case, the base is the top and the bottom. Everything else is a rectangle. So our bases are hexagons, our lateral faces are rectangles. This is a hexagonal prism. If you think about this as a glass, kind of a novelty glass, but we're going to fill it up with milk or water. First thing we're going to do is that liquid is going to touch the bottom and kind of spread out. It happens quick, but it still covers up the bottom. That's area. Then as we continue to pour it, it travels through the height. So we have to take into consideration not only the area of the bottom, but the height. Volume of a prism is the area of the base, because we're going to cover the base, and then we're going to multiply by the height because we're covering that base multiple times. Now you would think it would be A for area, but it's not. It's B because it's base area. So we're trying to remind you that you want to find the area of the base. Then you're going to multiply that by the height. So this is a generic formula for all prisms because we know the base is going to change. In example 1, we have a right triangle in the front of the picture and a matching right triangle in the back. So this is a triangular prism. Although the formula for prisms is B times H, the area of the base times the height, we're going to change it to go specifically with our picture. We want the area of the base, the area of a right triangle. That is 1/2 base times height. So all of this is your triangle. We still have to multiply by the height of the prism. So I'm going to put a P here for prism to remind me that that's a different height. We're going to come to our triangle and we're going to ask what is base and what is height of our triangle. Remember, they have to be perpendicular. So 2.5 is going to be our base and 6 is going to be our height of our triangle. The height of our prism is the distance from the front triangle to the back triangle. So the height of our prism is 3. When I plug in the numbers, I get a base of the triangle of 2.5, I get a height of the triangle of 6. So all of this is our triangle. You don't necessarily need to brackets, but I'm going to put those in there. And then the height of our prism is that 3, the distance from the front to the back, from the base to the base in this case. Then I'm going to just multiply them all out, and I'm going to get 22.5. So now I need a label. Remember that this was millimeters times another millimeters times another millimeters. So that's going to give me millimeters cubed. Remember, this is three-dimensional, so we're filling it with cubes. Our second example says a flower pot with the given dimensions needs to be filled with soil. How many cubic inches of soil will you need? So this is volume. Generically speaking, volume is the area of the base times the height for a prism, but we want it specific to this prism. So this prism has a trapezoid right here, So we're going to be looking for the area of a trapezoid. So the area of a trapezoid is the average of the bases times the height. So this is our trapezoid. But we still need the height of the prism. So let's come back and look at our trapezoid. So this is the first base and this is the second base. Well, there doesn't seem to be a number, but there is. It's right there, it's 14. So our second base is 14. So our first base is 8, our second base is 14. We're going to multiply or add them and divide by 2. Then the height of the the height of the trapezoid is from base to base. So it's perpendicular, so it's 10. So the height of the trapezoid is 10. So all of this is the trapezoid. So now we just need the height of the prism. So from the front to the back, in this case again, from trapezoid to trapezoid is 20. So the height of our prism is 20. Order of operations says we're going to have to get rid of the addition before we can multiply or divide. So 22 divided by 2 times 10 times 20 is 2,200 inches cubed. Again, it's inches cubed because it's three-dimensional, or we did inches times inches times